This machine learning, unless you know the history, then you cannot appreciate these things. I will tell you a story behind this. When we were students, in fact, when neural network, you will surprise, the first paper which before PhD I published in neural network in some conference in India and IIT Kharagpur, we are modeling a back propagation MLP of a synchronous generator. I got a student, just sake of fun, I'm doing it. And we wrote the program in Fortran. And implemented it, you will laugh now, PCXT. PCXT means it's a 8080 based processor. Or something 808, something, not a very small computer, okay? During that time I was in Adishi. When I went to England, Steve Billings has got a Son workstation that is based on the 80486 processor. You may not have heard it. 8080, 8085, 8086, 80186, 286, 386, 486. 1996, when I completed my PhD, I completed my PhD within 2.5 years. But my examination was a bit delayed because of the Christmas time. So nobody is there, it was delayed by 1 month because everybody went on leave. I'm supposed to come by January, but I came end of January. December, there is lots of sale goes on in England. I remember December 23rd, in the afternoon, I went to buy something from the floppy disk. You have not seen those disks, it's not there. 4-inch disk or something I went to, there's a shop called Office, who sells stationaries. When I'm going there, you'll surprise. Why I'm telling these things, it is relevant. Those people, in the afternoon I went, it's very gloomy, England is always gloomy. So they were putting something similar to computer and covering it up. Then I told, hey, what is that? Why you are covering it up? They told, no, we are not allowed to speak. Today you go and see the British Channel 4 or television, you will know it. On Boxing Day you come. Boxing Day means 26th. Because 25th is the Christmas Day, holiday, 26th. They did not tell me. Then I came here to house, to home. Then that's the advertisement in the television. The next generation computer is Pentium 1. Will be available for sale from Boxing Day. 1996, December 26th, in the British soil, in the entire world, those people did not show me. Because they say, no, we are not going to, suppose you say. Yeah. So you go and see, you come on Boxing Day, because the shop will be closed. Next day is holiday, next day is holiday. Now from Pentium 1, where are we now, right? 1996. Then what happens in between 1990s, this is 96 was the computers evolution. 1985, people who are working on signal processing must be knowing the person's name is Bernard Woodrow. Woodrow and Stone Adaptive Signal Processing book is very famous. Bernard Woodrow. He is one of the boss in this particular area, and then Rummel had this parallel processing and the computers. There is one guy, I met him in the Rio de Janeiro conference. He is one of the father of this neural network. I think he is Paul Werbs, W-E-R-O-B-S. He's an old fellow, okay? Going and sitting in the beach in the Atlantic in Rio de Janeiro, I've seen it. Big shots. He's written book and he's the father of the machine learning actually. He has many papers. He is the person who has developed these things. Neural network came up. 1990s. Everybody, entire world, everybody, they will say we are working on neural network, neural network, neural network. And I have seen in Adisi Raulkala, I am not naming the persons, it will be known. Neural network is a, no doubt machine learning, people are now talking, they change the name to neural network to machine learning now. Essentially machine learning is neural network when they say, although it is not the case. Linear system identification using neural network. I asked the guy, why the hell you are identifying a linear system using a neural network with a MLP based network? Is it worth? You tell me, you are all academics. A linear system, a simple discrete parametric model with a least square estimator who can do the job. Why the hell a neural network with the MLP based network, number of layers, there is activation functions, all these nonsense things there. What am I point? So that neural network which was developed during that time, now in recent years, people have given the name machine learning. Actually, machine learning does not only include neural network, but usually they mean the neural network. It is essential neural network based. There is a network, there is activation functions. Okay. The problem with the neural network is, it is very good in the approximation. Although, it can approximate not only the system dynamics, it can approximate the noise. Overfitting, very prone to overfitting. Because there's lots of number of weights are there. You got a point? You give me ample freedom. Suppose to a particular, your child, you give ample freedom. So what he will do? He will do anything, right? He will go to and take drugs also. Okay? He can do anything, right? Neural network is like this. He's a spoiled child. I always say this is a bloody spoiled child. That is we who have done it. Nothing is coming. Okay, increase the number of layers. Increase the number of weights. So why the hell I will increase the number of weights? System is very simple. So neural network, although it has got tremendous capability to approximate a function, it has got a significant drawback. The drawback is the weights of the neural network cannot be interpreted physically. That is the point. So machine learning algorithm that can work fine, but completely useless. Completely useless when I'm saying it. When the question of interpretation comes into picture. Suppose you fit a mass spring damper system model, M, F, K. You have got the model. Now you can say by changing the mass, this thing happen, right? So when you say changing the mass, you have in your mind what you are changing, right? I remember when we are studying applied mechanics, you are all academics, you tell 1 kg per meter square is more or 1 kg per centimeter square is more. Don't think. See, the students should understand that. 1 kg per meter square, that means you take 1 meter by 1 meter and put 1 kg. 1 kg per centimeter square, you take a 1 centimeter by 1 centimeter, then put a 1 kg. Where you will feel more natural, 1 kg per centimeter square. So that way the concept should come, right? Calculation has no meaning. What I point? So similarly, mass spring damper system, there is a model, you change the mass, now you know that the mass is changed, damper is changed, resistance is changed, so damping effect is changed. You change one weight. What is the physical significance you will get? Nothing, right? So machine learning algorithms are completely useless because it cannot be interpreted, right? But it's very good for prediction. Very good for prediction problem, right? Interpretation, zero, right? So if someone is saying that why you are using machine learning for control, working in this particular field for the last 35 years, I will say, I will dump this machine learning in the Pacific Ocean or Arabian Sea. But because students want to graduate and want to publish papers, therefore we are working on neural machine learning. Otherwise, there is no point. I'm telling these things very clear. We have just recently published a paper in a deep learning network in computers and electrical engineering. One of my PhD students from university just published, maybe 10, 15 days before. Okay, and still working on the DQN network. We are doing it. I'm not saying we are not doing it. Otherwise, you cannot survive, right? The students want. So, machine learning has its own problem, but it's a good predictor, no doubt about that. It's a good predictor, it has its own applications. But in control applications, ML can model system dynamics, detect faults, or learn optimal control policies. It can learn it, no doubt that. But it can model system dynamics without giving any interpretable capability. It can learn. Neural network can learn it, right? It can fit it. They adjust internal parameters, weights in a neural network to reduce error, right? Training and learning from data. Nowadays, you will find Google, Facebook, all these things. They have got a huge machine. I'll tell you, this is the exact thing I'll tell you. We have got a professor back in REC Raulkela, amateur astrologer. In India, he is amateur, not that professional. He is a professor, he is a very good person. And I asked one day, sir, how do you learn this astrology? He told, I did not learn anything, you see. In our house, my father was a priest in Puri. So, he is a good astrologer. So, we have got many charts, you see, training data. We have got many charts, many people's astrology charts. And the results are written there. So, I learned it, just mug it up. I know if at this point Brihaspati will be there, this will happen. If this point Shani will be there, this will happen. So I just mug it, there is no formula. So now I found somebody gives me, then I see it, okay. Jupiter is in this place, Rahu is in this place, so this will happen. You got a point? He is not learning anything, just mugging it up, overfitting, you see, core fitting. Okay, so he has told me. So, sir, they learn from the data. There's some training data. If someone's chart will come, whose chart is not there, he cannot say anything. The similar type of things should be there because he has learned from that, right? So, the Google engines, they will fail to do prediction because their training data may not have these type of things. Okay. Machine learning algorithms requires a lot of data for training. And that is the one of the disadvantage of the machine learning techniques, right? Given many input-output pairs, a neural network can map a system into this. But I will tell you, with 700 data points, we can map in most of the practical nonlinear systems into a simple parametric models. 700 data points is enough. Neural network will not do it. Neural network requires more number of data points. Okay. Machine learning has got one category supervised learning, another is unsupervised learning, reinforcement learning. Supervised learning, you know it because you give the same input to the model, same input to the system, mimic it, right? Supervised. Unsupervised learning is very simple. You are doing every day. You will find in this particular place, there are people from Maharashtra, people from Andhra, people from Tamil Nadu, right? So whenever you are sitting here, nobody is telling you, but you cluster. Okay, you learn from this. Okay, where are you from? Oh, I am from Chennai. Where are you from? I am from Madurai. Then we are together. Nobody is going to tell anything. You see, you learn by yourself, unsupervised learning, you cluster together and you make it, right? Unsupervised, there is nothing to tell. Children are playing, they will get connected accordingly. Reinforcement learning is a very fashionable catchword now, reinforcement learning, right? This is neither supervised nor unsupervised, right? Neither supervised learning or unsupervised. So reinforcement learning is like this. You do a job, you do your job, right? Now once you do your job, you will get a reward. You will get a reward. Say for example, I am teaching here. Professor Rahulkar told me that if you teach well, you will get T. If you don't teach well, you will get a chocolate. Got my point? So I don't know anything. So I am teaching. By the time I go out, he gave me a chocolate. That means I talked nonsense in my last lecture. You got my point? Because the reward is less, only small chocolate, not tea. Okay. Then he will say, you will teach excellent. I will give you a treat in Taj Hotel. Okay. So what suppose he is giving me a treat in a local hotel, then I say that my performance is bad, I have to still improve. Exactly the same principle, the things happen. Reinforcement learning, okay, you take action. You generate a control signal and see the performance, right? Then the learning policy will say, if it is good, then they will give you a reward. You will get a reward. That reward, that will decide that what action you have taken, you will continue with a similar type of action or you will revert to other type of action. Right? Second point is, because it depends on the reward, right? Which type of reward? That depends on the performance. Now suppose somebody say, if you will do these things, you will get 2 lakhs rupees. And somebody says, if you will do these things, you will get 1,000 rupees. So naturally you tell me where you will work better. 2 lakhs. So your performance is depending on the reward function, what you are getting the reward, right? Got a point? So reinforcement learning like this, okay? Nobody is telling anything. It is unsupervised. Nobody is telling anything. You work. Why it is also not unsupervised and supervised? You are also getting a feedback. There is little bit of supervision is there. You are getting a feedback. Okay. So here you see, reinforcement learning is not supervised because it does not learn from the input output pairs. It just takes action. It is not unsupervised also because you are getting a reward. Okay, so from the reward you can know whether you are doing good or you are doing bad. Got the concept here? And which is critical in reinforcement learning? Critical is the reward function. Depending on the reward function design, if you change it, the performance of the reinforcement algorithm will change. Very fashionable catchword now. Reinforcement learning, everybody is using reinforcement learning now. You can read all these things. See, all these things I wrote it here. This is just for sake of delivering lecture. I don't have that slides. I think I kept somewhere. Fuzzy controller. Many people, anybody working on fuzzy controller, students? Fuzzy controllers. L14 developed the fuzzy controller and fuzzy principles, all these things. There is a guy in the MIT lab who works in the optimal control. So in a keynote speech, I have not gone there to that conference, but I have got the slides. Somewhere I lost it. I will find out somewhere. You will be surprised. The way he blasted L14 in that keynote speech, he says that your fuzzy controller can do everything, but I can show you that the optimal control can straightway do the same thing what your fuzzy control is doing. Fuzzy control is not superior. I can show it clearly. So similarly, people say machine learning can do many great things, but then many other controllers can also do the same job, right? There is no need of machine learning. Why are very complex things? It requires a lots of data sets, right? The reinforcement learning is becoming popular because it does not require lots of data. You change and also you don't need anything. You just get an action, you perform one control action, get a reward. Depending on the reward, you change your action, right? But see, these things, machine learning can generalize well. People are writing it. I just copied it from somewhere, but I don't agree. Generalization capability of the machine learning is a very difficult problem because it unnecessarily overfit. The bias variance dilemma is a serious problem. Okay. So what we are writing here, it has, you must, because you are academics, therefore I am telling you. You must be very careful, right? I will give an example. 2006, I was in a conference in Singapore. In the Singapore conference, the keynote speech is being given by the person Lornat Leung from Sweden. He is the #1 person in system identification. Around 500 people are sitting in the Hyatt. I remember he is delivering, Lornat Leung is talking. Lornat Leung is a big boss, #1. There is a person on the backside, myself and Eduardo were sitting there. He asked questions. He told Professor Leung, the results which you are showing is wrong. I looked at who is telling Lornat Leung is talking. Who is shouting in the conference, keynote speech that is wrong? Lornat Leung is a very gentleman. He told, no, how can you say it is wrong? No, I have got 11 PhD students. I have taken this example, it did not work. Why you are showing this result here? People are there like this. You got a point? This type of generalization well is the standard thing. Generalization well, how can we generalize? The many number data is corrupted by noise. There are so many words. It will overfit. It will overfit. Generalization capability is an extremely difficult thing. Okay. Now see here. Classical controllers PID, MPC rely on accurate system models, struggle with nonlinearities, uncertainty and dynamic environments, which is not true actually because MPC is there for nonlinear systems as well, but doesn't matter. This is model-free learning from interaction. That is the one thing. It does not require any model. That's the advantage. Capable of discovering optimal policies based on the reward. It can automatically learn. Because I am not getting any reward, that means I have to change my action. Bridges control theory with machine learning. I will tell you from my experience, machine learning can be used as a supplement to the classical control. Machine learning can be used as a just like a dessert. A desert cannot be your full meal. Full meal will be rice, chapati, curry, right? That is the full meal. Desert is the machine learning. It is just complemented. You cannot use machine learning as the major thing. You got my point? So that point keep in mind as in academics. You should be very careful. Bridges, control theory and machine learning. I think I mentioned somewhere. Reinforcement learning is a branch of machine learning where an agent, just like in genetic algorithms, we have chromosomes. So here you have the agent. Agent is the controller. The agent is taking an action means the controller is generating an output. Agent is the controller. The name agent in reinforcement learning terminology is the controller. You see, reinforcement learning is a branch of machine learning where an agent, I have mentioned controller, learns to make a decision by interacting with the environment. Environment is the system. Environment is the system. So agent is the controller, environment is the system, and that is the state. State means the same thing. System states. Maximize the cumulative reward over time. How much? So it will go on changing its action until it gets more reward. Unlike supervised learning, which relies on labeled data, reinforcement learning is based on the idea from learning from trial and error. It will learn it, you see, learning from trial and error. It generates an action, do not get any reward, it will change the action. Get the reward, good reward, modify it. I mean, reinforce the same action. The agent takes action, that is, agent generates some control actions, controller, in an environment, in a system, observes the outcome of, in terms of rewards or penalties, and adjusts its strategy to maximize the long-term cumulative reward. Okay. See here, standard control theory, reference, controller, manipulative variable, plant, right? Now here you see, the same thing you see, environment is the system, right? The system is giving you states, okay, the output or anything. Agent is the controller. The controller will take the reward from the system will give the reward, and it will observe the state, and depending on the policy, it will take action. Policy means, suppose, say, for example, agent is the controller. So it has got a policy that if I get this reward, these things, I will do it. Now suppose he does it, and he is not getting any reward. So you change the policy. Change the policy means change the control algorithm, little bit. Okay, so that's the policy. And you change the policy update. Policy update means how you, just like we do it. We don't get any reward. Suppose you are working in the power system, and you are not getting any reward from the department. So you change the policy that is from power system, you change to signal processing. Okay, and they get the reward. Yeah. This agent is essentially a controller. Yes, the policy change it, depending on the reward. See here, I have mentioned the relationship. Now this is a DC motor. The program is there. I don't know the program code I have given you somewhere. This reinforcement learning controller, you see here. Set point is 300 radian per second. Sorry. Then it changed to 275 radian. Now see here. And then it changed to here. The reward function is here. The reinforcement learning controller. right? It is working. MATLAB code is there. These things I cannot tell more about that because by the time I was too busy, I told my PhD student, Gunaman, he's an Indonesian chap. So he did it, he sent it. If you need anything, if it doesn't work, then you just send me an email or to Professor Rahulkar and I can pass it to him. So he will give you the code. Similarly, another example here also, automatic voltage regulator. Again, you see the reward function changed here. The reward function, we change it. Now, this is the response here. Voltage output. The code is here. The code is there. You see, commonly used design terms and the reward is here. Different types of rewards. It all depends. You change the reward function, things will change. That you have to do the research on that. There are many people are working on the reinforcement learning controller, changing the reward. Okay. Yeah, same thing. These handouts are given to you. Yeah. Only the Lyapunov stability handout, I'll change it and the value means the reward-based function. Policy, they are almost the same, you see. What is that? I don't have an answer to that actually. I don't remember, it's not in my mind. Yeah? No, cost function is different. There is no relationship. You decide what reward you will give. No question of cost function. You see, given an analogy, things will happen. Suppose the cost function is, suppose you have, your child is there. You decide your cost function that how much mark you secure and what is the error between the 100 and the mark. That is the cost function. Now, based on the cost function, this is the cost function for all of us, you. For you, and the same cost function I am also using. The difference between the mark you secured in the exam and the 100 mark. That square is the cost function for all of us. But you have told to your child that you will get 95. Okay? I will take to Taj Hotel for dinner and I will tell my child that if you get 95%, I will take you to the beach. And other person will tell his child, if you get 95%, I will give you a bicycle. So that reward, the same cost function is same, but the reward is different. That depends on you. You got my point? So cost function is same, but reward is different. That you decide. Deep learning, again this deep learning. Deep learning means multi-layer perceptron. I'm telling when at the beginning it came, the people started developing theory, how many number of neurons, what is the type of the activation function, okay? That will impact the performance. That is the usual research, 1990s, people do it. Number of layers also was there. Then suddenly a theory came, radial basis function network came, and it proved that any nonlinear system can be mapped by a single layer. So that thing went away. No question of number of layers. Earlier MLP-based network. This convolution neural network, CNN, or that is called the deep neural network, it came with the application in mind, the image processing applications. Deep network. There are multiple layers, all these things, okay? People are using in control. People are using control, I am telling you, not that people are intelligent. I ask my students, they are all saying we are using deep network. I told, how come these students are there using deep neural network? They say, sir, we have got a toolbox available. Reinforcement learning toolbox is available. Deep neural network toolbox is available. The neural network toolbox is available. Okay? What do you learn from that? Nothing learning. The machine is learning. You are not learning anything. You just key in. I always tell to my students, I can pick up someone from the Queen Street and they can do the job. What the hell you are doing? So deep neural network, so there is no need of understanding anything, why it is happening, right? There is one group who was working on the power quality, they are doing the final year projects. They are using a deep neural network. Deep neural network will generate features. They will generate features and classify it. Which features they are generating, you don't know. Automatically, you see, there are so many layers. Which feature, they will automatic feature generation. Which features, you don't know. Whereas you generate features using wavelets, using S transform or anything, you know it. Here you don't know it. Everything is black box. What people are doing it, you do it. No one knows. See, when you are sitting, understand the point, when you are sitting in the computer, you are not writing the program. What is the point in putting 5 layers or 6 layers? You just put it and you see some results, you get it. It is completely bogus. You got to, now you don't have any clue. Even reinforcement learning controller, I remember when Joey was doing my PhD in 2018, she was writing program, reinforcement learning controller. Gunman is doing, I told Gunman, what is that? No, Dr. Swami, RL toolbox is there. Surprised. As an academic, should I encourage? I will not encourage. But this is a part of the game. We have our own career and all these things. The boss is sitting there. Okay, this is recorded, I don't care. Okay. You got a point? Is it necessary to use it? Why I am telling these things to? I can tell with full confidence that I am able to tell it because I have worked in neural network. I have worked in the classical control. I have worked in the LQR. I have worked in the fuzzy logic. I have done all these things myself. I have worked in mathematical control theory, proving lemma theorem, all these things. I have also worked in power system. I have worked in system identification. If you see my publication profile, I am not telling as a proud thing. Because I have done in many cases, I can tell. Steve Billings could tell because he has gotten 800, 900 papers. He has published around 50 to 100 papers in neural network. He can tell neural network is useless. He himself has published 100 papers. You got my point? We know what is that. Okay. So, I think we will close the lecture today from here. And thank you very much.